Hello, my name is Jake Raby, and I own a company called Flat 6 Innovations. I'm the inventor and developer of the IMS solution, as well as many other IMS retrofit products offered by Ellen Engineering. A lot like this very first IMS retrofit, things have happened over the years to make products better. Now, back in the old days, this was made by hand. Today, all these products are made in a computer numerically controlled type of environment, and there's good repeatability, and there's also thousands of installations been carried out. So over that period of time, there's been a lot of questions asked, a lot of people hitting small snags, hurdles, roadblocks, and experiencing some things that not even we've experienced through the 700 plus IMS retrofit procedures that have been carried out under our roof at Flat 6 Innovations. So the purpose of today's video is to help you understand 3 points. One would be the pre-qualification procedure. We want to make sure that you're able to understand how to properly verify the vitals of an engine to make sure it's healthy enough to be retrofitted as a preventative procedure. I want to help you always remember that these are not repair products. All IMS retrofit products are designed as preventative installations. That dates all the way back to IMS retrofit number 1, the very first time we'd ever retrofitted an IMS bearing. So that being said, we're also going to go over the procedure itself, how to make sure that you've got everything in line to safely and correctly carry out an IMS solution or IMS retrofit procedure. And third, and lastly, we're going to go over the things that it takes to properly care for your engine after it's been retrofitted with these technologies, because the type of oil you use, your oil service intervals, and a lot of things will be impacted from now until the time that you basically sell or stop driving your car. So we're going to head downstairs to my work area and we're going to get started. Okay, we're going to begin the IMS solution installation with the pre-qualification procedure. We're going to follow the steps in the installation manual that comes with the IMS solution. As you can see here, we have the pre-qualification procedure checklist. This is what we're going to be following verbatim to carry out the pre-qualification. Now, some people ask why we do pre-qualification, and the answer to that is very simple. We want to make sure that the engine does not have existing damage that could make it basically a very bad investment and put the products that you're going to be installing in undue jeopardy. That being said, we're going to illustrate the interrogation of the ECU for the procedure using the durometric. This is a very common enthusiast-based tool that also has a pro version that shops can use. I'm just going to go here and basically select the car that we're working with, and this is going to help us interrogate the engine's ECU, our engine control unit, our DME as they call it, the digital motor electronics, our brain. So this car is a 2002, so it's the ME 7.8 for 2002 to 2004 non-turbo and GT3 models. I'm going to select that. Okay, I'm just going to do a few checks here before I actually fire the car up, because we'll kind of have to reboot this process when we do that. I'm going to open up the engine module, as you can see here. First, I'm going to look and see if there's any stored fault codes. And there are no faults found, as you can see. Okay, so here we also are wanting to go to the information tab. And this will tell us how many over-revs this car has seen. So the number of ignitions in range 1 is 11,805. Number of ignitions range 2 has just had 1, which is basically just an anomaly. So this is not 11,000 over-revs. This means that there has been that many ignition cycles basically obstructed or killed by the over-rev limiter that's built into the ECU. Now, if your car is newer than this one, it will have 6 ranges, not just 2. So this is just a general overview of what you may experience with your own particular car. So after we've done that, we're going to, at that point in time, fire up the car and start looking at a few other things. One thing that I tend to do at this point in time also is to look at the ready status. So if we go to the ready status here, you can see that we pass on all of these. This tells us that no one has tried to cheat us. They haven't just turned off a check engine light because the engine had a problem. and wanted to make it look like that everything was okay when it really wasn't. So if you have pass on all 5 of these, then the car has been in the ready status for an emissions test, and that basically means it has had no problems in the last 20 driving cycles or roughly 350 or so miles. So with that being said, we're going to start the second part of the ECU interrogation by starting the car. Okay, now that we've got the engine running, we want to make sure it's at operating temperature. Now it'll fool you sometimes because the coolant temperature will actually get hotter faster than the oil temperature. So once your coolant temperature gauge has got to around 180, let it stay there for like 10 minutes so the oil temperature is warm. Now the reason for that is these engines and the drive system for the camshafts is hydraulically actuated. So you want to make sure that you don't have any false problems going on because the oil is not hot enough. So if you let it stay at 180 for about 10 or 15 minutes or come in after driving the car to do this, that's fine. So I'm going to go to the actual values here. Now all scan tools will be able to do something similar to this. The Durametric is just very easy to work with, and a lot of shops use it because of that. It's also cost effective, and even a do-it-yourselfer can afford to buy this. Even the Pro version is still cheap. A lot of scan tools are $20,000, $30,000. This is less than $1,000. So I'm going to go here and start checking for our first point of concern. That is the camshaft deviations. So this is the amount of crank position or crank degrees we have between both banks of the valve train and the crankshaft. So bank 1 is 1.41 degrees, bank 2 is 0.16 of a degree. Now you notice here that's a positive value and that's a negative value, but they are still within 6 degrees. Now a lot of shops would follow the Porsche directive for this, being 6 degrees as a maximum allowable for the amount of deviation you can have between both banks. Here at Flat 6 Innovations, and also with all the certified installers for the IMS solution, anything over 4 degrees is an area of concern that we feel should be corrected before you jump into doing a solution install or any retrofit. And a lot of people ask why that is. Well, the worst thing that can happen is you spend a lot of money to do something like an IMS solution, this wasn't checked or it was overlooked, and then a few weeks or a few months down the road you have a scenario where now you get a check engine light for high cam deviations, and you then would blame a shop for the work that they've done because they were the last hands that went in there. This is a good way for the shop to protect themselves and also to help protect your investment by making sure that you've done everything you could to pre-qualify it. That's why we have this pre-qualification procedure, and that's why we urge you to follow this verbatim. Okay, so now what I've got pulled up on the screen here is the rough running index of the engine. So this is important because it may help us see if we have any cylinders that are trying to misfire or maybe even some cylinder bore scoring going on. This is something you don't hear a lot of people talking about, but it gives us a graphic image of how these the engine cylinders are performing. You know, even a bad spark plug can make the engine run a little bit rougher on one cylinder than another. But what I'm seeing here is that they're all just kind of bouncing around, and they're all very close to the same. They're all less than 1, okay? So if you ever have one of these that jumps up and it's like 4 or 5, or I've seen them at 40 before, then that cylinder is going to be an area of concern that you want to look at. Again, we're just trying to get a picture of the vital signs of the engine before we perform this invasive work. It's a lot like going into the doctor and the first thing they do is pull your vital signs before they do any procedure. We're just collecting this vital data to act as the vital signs for the engine before we kind of go in there and take care of it. Okay, so now the last thing we're going to check from our actual values perspective is just the fuel trim. So this is another video to help you understand how fuel trim works. We're not going to do that today. You can go Google fuel trim and FRA and FRAU and all these other things, long-term and short-term fuel trim. But basically, we're just looking for the values to be around 1. And anything up to about 1.05 is good. Anything less than like 0.95 is good. And these are very stable, 1.02 and 0.99. Now we typically will do this with the engine at idle, fully warmed up, with the air conditioning turned off so the idle speed is down, just so we are able to have those good repeatable results and don't have the AC cycling on and things like that, okay? So now that we've done that, I'm gonna kind of go over a little bit about what we've learned about this engine. We're gonna go back and look at those over-revs again. I want to bring that back up to your attention, since that's really the only thing of interest here that I've seen that I want to bring over and kind of go over with you again. Okay, so now we're back here in the information tab of the Durometric, and we are seeing that we had that number of ignitions in range 1, 11,805, okay? Now, again, that's not how many times the engine's been over-revved. You can take that number to 65,556, I believe it is, because I've had a car that I did that to. It was one of my own, and I used it for test work, and I had that many over-revs. That wasn't that many times it had been over-revved. That was how many ignition cycles had basically been interrupted. So this one's 11,805. Now, the main thing I want to show you here is the operating hours counter now is 1,856 hours. So this car has 1,856 hours of runtime on it. Now, at 1,854 hours, 2 hours ago, basically, somebody missed a shift. They just hit the over-rev, okay? It went to this range 1 over-rev. That was not a zing. It was not anything catastrophic. They literally touched the over-rev limiter one time. That's very easy to do. If you don't shift, for a split second sometimes, it'll pick up that over-rev. Now, that's nothing to be concerned about, but it's just information that we're looking at. So, the one over-rev we have, the one instance, which I'm sure is just a phantom thing because there's only one that's in range 2, was at 1,026 hours. So, if we had seen more than like 50 rev counts there, that would tell me that was a more significant over-rev. That means somebody mechanically missed a shift. They missed a gear. They went from 5th gear to 2nd gear. They went from 4th to 3rd when they were trying to go 4th to 5th. They have a short shift kit in the car. They're not used to it, and they haven't learned things about it. It's really easy to miss those shifts. So I would not be worried about this car. But I wanted to bring us back to this because this is the only kind of gripe that I found while doing my interrogation with this car. And it's something that you need to understand. Now, what this means, if you see a lot of numbers here, the car has been tracked or has been driven very hard, okay? If you see that number up in the thousands, that is a significant amount of over-revs this car has seen. And usually that goes hand in hand with a lot of track time. Now, what I like to do, if I've seen a lot of numbers in that range 2, and we are within 50 operating hours, I start thinking that there's a problem that could jump up, and I will let my customer know that. And either he would have to sign a waiver with understanding that there was a lot of over-revs in the car, or we would not do the procedure, okay? So this is certainly grounds for disqualification for the IMS pre-qualification procedure. And if you have a later car that has the 6 different ranges, you're worried about ranges 3 through 6 more than you are 1 through 3. So when you see something from range 4, 5, and 6, those are significant. Basically, all the factory did was break down range 1 with this car into 3 ranges, 1, 2, and 3, and break down range 2 with this car into basically 4, 5, and 6. So with a newer car, if you start seeing a lot of range 4s, 5s, or certainly 6s, that's a big deal. You're probably not going to see a range 5 or 6 because a lot of times those engines will fail pretty soon thereafter. So I just wanted to help you understand that. At this point in time, we have finished the pre-qualification procedure for the ECU interrogation with this car. Now we're going to move on and we're going to look at the crankcase manometer reading as we move forward through our checklist. Okay, so now we have the manometer here that comes from CR Tools, and this is an application-specific tool made for the Porsche air oil separator. I'm going to basically show you how this functions. We take off the original oil cap, set it aside. This tool actually incorporates a genuine oil cap. And then we want to make sure that we have it zeroed out. So we are at 0.00, meaning that we're reading ambient pressure. And again, you want to make sure the engine is warmed up. It's good to do this just after you've finished the ECU interrogation, so everything's still nice and warm. Now we're going to go ahead and start up the car. Okay, so we want to let it idle and stabilize, so we're reading around 4.77. The perfect number for this in our operating environment is a 5. We're at about 700 feet above sea level here, where the facility is that we're doing this work. So a 5 is perfect here. So this AOS is showing us that, you know, it could probably stand to be replaced. It's not on the low side, but it's definitely not exactly where we want it to be. If you see this number in the 6s and 7s or higher than that, it is definitely too high, okay? So when I start seeing numbers down around the 4.5 to 4.6 range, I also start worrying about the condition of the engine cylinders. We're going to carry out a bore scope evaluation as well later on to make sure we don't have any bore scoring going on at the present time. But one thing that can lead to an air oil separator not having enough vacuum is the condition of the engine components, okay? So if you notice here, the unit of measure is INWC. This means inches of water column. You want to make sure that you have the proper manometer for this, like the CR Tools version, and even it has different modes. It also has an inches of mercury column. So you want to make sure you see the INWC for inches of water column. We're going to have an 8mm hex to remove the oil drain plug. We are going to collect an oil sample in the bottle here. We're going to get a midstream sample that will be collected about 5 seconds or so into the draining process. Okay, it's going to be very important to make sure you drain as much of the engine's oil as possible. It's very good to do this while the engine is warm, especially if it's a cold environment when you're doing this type of work. It's cold outside. The hotter the engine oil is, the quicker it will drain and the more thoroughly it will drain. Our next process here is going to be to remove these 13 perimeter bolts on the oil drain pan and perform an inspection of the sump plate. So it's important to get all the oil out of there. Also, I'd like to mention, if the engine is equipped with the LN Engineering magnetic drain plug, you would want to look at that drain plug to ensure that there's no ferromagnetic debris collected on the drain plug. You may want to document how much debris is on the plug and send that into LN Engineering as part of the pre-qualification process if they ask for it. Okay, now we're going to go ahead and start the removal process of these perimeter bolts on the oil sump plate. These are very small bolts, and you want to refrain from using impact tools to do this job. Okay, the sealant that's been applied to the sump plate is going to kind of keep it in place. You can see that all of our fasteners have been extracted. It is common practice to need a tool like a prying device, a large screwdriver, pry bar, whatever, to go to the tabs that are located on the side of the sump plate that are actually put there for this purpose of prying. And you'll see some more oil coming there. And keep in mind, you're going to have quite a bit of oil that's been trapped on top of this plate that's going to try to come out. At this point in time, you can try to put the drain plug back in to keep more of that in place if you'd like to. And you want to try to keep this level as it comes down, because it's going to have quite a bit of debris on top of it that we want to look at if you've got a bad scenario going on. Okay, the next step is we're going to remove the engine's oil filter. And we want to be careful here because we're going to also have to inspect the oil that comes out of the filter housing, and as well as the oil that's maybe trapped in the filter along with any debris. So you want to hold the filter housing. And when it comes off, keep it nice and level and watch for the oil to drain. A lot of times your filter will stay attached to the engine as you see here. You just want to do this and collect it back into the filter housing, and then now we will go to some brighter light to be able to inspect it. Okay, with the oil filter and housing removed, we want to perform another test, and we're going to make sure that there's been no debris make it past the oil filter. A good way to do that is we go to the port where the oil filter goes into the engine from the filter, and we look for any kind of debris that may be on the finger here. It usually will be shiny. You might want to take this into some bright light. Again, sunlight works very good. Okay, so now we have the oil filter in the wash tank here. We're just going to pull the filter out of the housing, and we're going to set it off to the side. We'll be inspecting the filter a little bit later. Now we're going to pour out a little bit of the oil here, just so we get to the very bottom. And always pay attention to the oil that you're dumping out as well. You see, there's nothing glittery or shiny coming out of this oil. And then now we can look in the bottom of that filter housing to see if there's any debris collected there. Now, any debris that's too heavy to have been suspended in the oil and got caught by the filter a lot of times will end up here. This is a window to the soul of the engine. So this one looks really clean. I don't see anything here that would be suspect. There's no large debris or anything like that. So now we're going to move forward with cleaning up the filter housing, and then we'll actually cut the filter apart and inspect it. All right, so I would like to add that it's important that you have at least a couple to maybe 3,000 miles on the oil that is in the engine when you perform these inspections. Otherwise, things like this filter may show little to no debris, but only have that result due to the fact that the oil has not been used long enough. We removed the sump plate. We now have it in the parts washer here. This one looks really good, but we're going to do more than just a visual inspection. We've got a lot of bright light in our workshop here. If you don't have bright light like this, it might be a good idea to take it outside in the sunlight. You always want to kind of swirl this around a little bit and see if you can see any glitter. Sunlight will really wake that up a lot if you do have anything. This one does look superb. Now it's a good idea to take a magnet and introduce that magnet into this pool of oil that's left, and just make sure that you don't find anything else that's ferromagnetic. If you end up finding something that alerts you, you would want to send a ticket through the IMS solution ticketing system on LN Engineering and ask if something may be out of the ordinary. So here, that magnet's just as clean as it was when I introduced it. So at this point in time, this engine would be cleared for an IMS solution retrofit, considering that the pre-qualification is good to go. Okay, so here we're performing a bore scope inspection of the engine cylinder walls. We're going to look 360 degrees around each cylinder. We're looking for puddles of oil, looking for scoring, looking for cracks or anything that may be abnormal. And then here, we're preparing the surface of the sump plate to remove all the old sealant and square it up, make sure there's no dents or dings in that surface. And we're going to do the same thing to the crankcase. A razor blade backwards across the surface is great. And then finally, we're going to install and torque the 13 fasteners that hold the sump plate into place.